drop a comment in the message box. So the agenda for this morning's webinar, we're going to look at safety and security. Why is machinery safety transforming? The information versus operational technology, threats to the safety-related parts of the control system. We'll look at cybersecurity. We'll look at machinery-related standards, requirements to machine manufacturers and end users. We'll then look at risk assessments via zones and conduits. We'll then go into foundational requirements, and then we'll look at countermeasures. Finally, what I would say is that we're doing something new this time, is that we're going to talk about countermeasures during this webinar, but in 2 weeks' time, or just under, on Thursday the 23rd, we'll be doing some live demonstrations as well. So safety and security. So security vulnerabilities enable machinery safety to be manipulated. And so we're all familiar with machinery safety. This protects your staff from hazards due to the machine itself. But security protects your machine and its data from manipulation from unauthorized access. So we're protecting against corruption. So with security aspects, we have physical security. So this protects the machine from personnel. So i.e., we're protected against unauthorized access, operator errors, etc. So even to a HMI screen. And then we have information technology security, and this is where we're protecting devices and data from attackers. And that could even be in-house, or it could be remote. So why is machinery safety in transformation? So if we look at kind of like industry, from the early days of industry, really, from steam power, weaving looms, now we have the terminology of Industry 4.0, Internet of Things. So there's now an ever increasing need and desire to interconnect everything together, so we can see what's happening in real time throughout the world. And so as a part of that, security has become an integral part of our everyday lives. So if we look at how things stand currently, safety really is covered by, or was covered by, the Machinery Directive, the Supply Machinery Safety Regulations, and security has kind of been left kind of to one side. It's not been really looked at. But because of this increase in digitalization and networking within the operational side of manufacturing, we need to now take this into account. And so there will be changes up and coming, the machinery regulation being one of them, where it will now look at both safety and security. So it's a changing process, really. So we have the machinery regulation, and this has been published. We have the Network Information Systems, NIS2, which is also published and due to be implemented. And then we have the Cyber Resilience Act, again, has been published and is due to come into force. So the NIS2 directive, we're unsure at this stage whether or not the UK government is going to take this and incorporate it into UK law with regards to Brexit. But we do have NIS, and this pretty much covers large utility companies. But the NIS2 directive is looking at that, but also manufacturers of machinery and equipment. We have the machinery regulations. So this was published last year, and this will now look at protection against corruption, so cybersecurity, and cybersecurity will also most likely form a part of ISO 12100 for risk assessments. And then we have the Cyber Resilience Act, which is expected later on this year, where if there's products with digital elements, they should be delivered without any known vulnerabilities. So as it stands, if you're a manufacturer of electronic equipment with digital elements, you could actually sell those if you know that there are vulnerabilities with regards to cybersecurity. From October 2024, if you know that there are vulnerabilities within those products, then you shouldn't be placing those on the market. So it's an ever-changing process, really. So with the ever-increasing need for connectivity, we have our energy providers or our utilities, we have our manufacturers of machinery, and then we have our manufacturers of electrical equipment. And so NIS2 will become essential for utilities and large companies. It'll become an important entity for manufacturers of machinery and for manufacturers of electrical equipment. The machinery regulation will come into effect in 2027 for manufacturers of machinery, and the Cyber Resilience Act will come into force for manufacturers of electrical equipment. So you can see how they're all interlinked together. So IT versus OT. So how does information technology and operational technology interact? So we're all familiar with IT, a term that's been around for many, many years. We've all got our VPNs, firewalls, everything in place. Company policies, procedures of what you can and can't do. But when it comes to the operational technology, the OT side has kind of been left to its own devices. But with this need to connect to our IT network, we need to have a look at what products, etc., are being used within that OT network and protect against cyber threats. And the reason why OT systems are generally more vulnerable than existing IT office systems really is longer running times. When you look at the life cycle, laptops, for instance, we have those for 2-3 years, and generally they then come to the end of life. Whereas a machine, that could be 20 years plus. You need to have a look at steady growth, really, especially within the last 10 years of cybersecurity threats. And this is due to high level of networking within the plants, technological progress, consolidation of technologies, rising costs of the infrastructure to implement, and therefore the high capital investment. And these are all things really that put pressure on our OT network. So what's the differences really? So with safety, it generally requires no frequent updates. Once we purchase our machine, we install it, we carry out pure assessment, and it's left operating year on year. Unless there's an incident or any kind of modifications, there's no updates that are required. Whereas with security, that requires high frequency updates. We're always getting messages on our phones, on our laptops that we need to install the latest firmware, etc. So there's a high level of frequency with regards to updates there. Safety is mainly a product business, where for security it's solutions. Primary concerns generally are manufacturers with safety, for security, machine end users. So if we look at achieving our security objectives, what we class as CIA is kind of our #1 priority. And so that's confidentiality. So data may only be read or modified by authorized users. And this applies for access to stored data as well as during data transmission. We then have integrity. So this data may not unknowingly be modified, and all changes must be traceable. And then finally, we have the availability, and this is the prevention of system failures. So access to data must be guaranteed within an agreed timescale. And so our confidentiality, integrity, and availability, the priorities of those is really different between our IT and our OT networks. So for IT, confidentiality typically takes #1 priority, followed by the integrity and then the availability. And what we mean by that is, our data, we want to keep that, stored and secured. We don't want any GDPR breaches, for instance. With regards to availability, if a laptop was to fail or a printer fails in an office, generally there is a spare one or a way of working around. So that's why priority is less. With OT, we have safety that comes into effect, but we also now have changes within the priority. So availability is generally the highest priority because, you know, if your manufacturing line goes down, you can't just get another one from the stores, for instance. You know, you've only got one. Integrity generally can be the same, and then confidentiality is normally less. So what happens is if there is a threat really to our safety-related part of control system. So, you know, the relationship between threats, vulnerabilities, and consequences, you know, all have a direct risk, a security risk on our safety system. And so these threats basically will expose any vulnerabilities that we have, and those vulnerabilities will then have a consequence on the performance of our safety functions. And so what we need to do is introduce countermeasures to be able to combat against those, and we'll run through that in more detail. And so if we look at the security with regards to the machine control system, a threat can succeed, or if it's exploited, that will then create a vulnerability, and the consequence of that could be on an asset, and that could either be components or human, and that could lead to a security risk to the safety control system. And then that, you know, it doesn't have to be that. Other consequences could be environmental impact, it could be loss of property, business interruptions, etc. And that security risk could have an impact or a trigger on the failure or the malfunction of the safety functions no longer performing as intended, and that can then lead to degradation of risk reduction measures. So, for instance, you might get unintended movement, or there might be an increased reaction time to a light curtain, for instance, and that would result in harm potentially. And so, you know, therefore, an online connection to a safety controller, physical access to the safety parts of the control system without any authorization, that's got a consequence on the machine. That leads to a security risk, and the impact of that is safety valves being opened due to malware installed on the PLC. That can lead to an increase of risk, so there's no safety output because that's not activated, and that could lead to an explosion. So it's just an example there. So countermeasures to machinery and related cybersecurity and machinery related standards. So ISO 27000, this is information security management systems. So this is really for organizational implementation really. So it looks at information security management systems. It gives you information on security, cybersecurity, privacy protection, so information on those cybersecurity controls, how you can do implementation, so there's guidance on there, monitoring measures, analysis and evaluation, and then it also gives information and code of practice for information security controls based on some cloud services. We then have IEC 62443, which is security for industrial automation and control systems, and this runs through application and products, and it's split into various parts. So there's general requirements, then policies and procedures, so that's for the organization. We have system requirements, and then we've broken down into components, and I'll go through these in more detail. So security really changing from a can to a must with new laws and standards. So with the new machinery regulation, this will be valid from the 20th of January 2027. Up until then, you know, the current machinery directive would apply, albeit that's in the EU. In the UK, we have the supply machinery safety regulations. But at this moment, it's unclear what the UK government would do come the 20th of January 2027. They have said that they'd indefinitely take CE marked goods. Because there is such a drastic change though between the machinery directive and the regulation, there may be some changes to that stance closer to that point. We then also have technical report 22053, which talks about safeguarding support systems, and we'll go through that in more detail. And then we have technical report 63074, and that is a technical report on implementing 62443. So in the worst case, you wouldn't be CE compliant anymore if you didn't meet the new machinery regulations. Potentially, well, anonymous non-individualized keys, mechanical keys, which are typically permanently stuck in control panels, where you can change from run to jog, they will be phased out. They wouldn't be allowed anymore because you can't identify and authenticate who's using those. And then we'll go through these with identification and authentication, control of usage, and restricted data flow with VPNs, etc. We'll run through these to see how you can become compliant with the new regulations. And then just a bit from Pilts on a sales pitch, really. So the products that we are releasing, such as the Pit Reader and the Security Bridge, these are both products that are developed according to the security development lifecycle process of 62443, and we have third-party accreditation to show that. So the machinery regulation is becoming a directive, is becoming a regulation, and it's going to talk about protection against cyber threats, and this becomes an essential requirement. So it will form part of the EHSRs, the essential and safety requirements, and security for machinery safety becomes mandatory. So as mentioned, in the worst case, you'd no longer be CE compliant with your machine in the future. So what does that mean? So we have emerging digital technologies with regards to security. There's no direct reference to the NIS directive, but it still discusses aspects of cyber security within the regulation. And we look at protection against corruption. So this would actually form a new EHSR 1.1.9, and this defines requirements for interference, really, so protection against corruption. The linking of devices, so USBs, for example, and remote devices, such as the internet, must not lead to dangerous situations. So the machinery product shall collect evidence of legitimate or illegitimate intervention in the software or a modification of the software installed on the machinery product or its configuration. So it's not just, what we mean by that is it's not just somebody that is doing a malicious attack. It could actually be somebody that's making a mistake, an employee or a disgruntled employee in this case. And then we've got the safety and reliability of our control system, and this is EHSR 1.2.1, and this will be a rewrite, really. And the paragraph here is that it must, so it can withstand malicious attempts from third parties, shall not lead to hazardous situations, shall be protected against accidental or intentional corruption. And so again, what we mean by that is that, you know, this isn't necessarily just either a state sponsored or somebody in their bedroom trying to gain access intentionally to a control system. It could be a maintenance engineer, or it could be an employee that has just made a mistake. You know, so it's both malicious and non-malicious. So safety and security really is becoming safe and secure. So if we look at safeguarding support systems, this is where typically you would have a mechanical key in a panel, and that key would be in machine run mode, and then you may have to run it to a jog mode, for instance. You know, when we look at technical report 22053, we need to look at safeguarding support systems, and what these allow are identification of authorized personnel. There's verification that authorization for that selected task matches the identification of the person or the personnel. It informs the user of that authorized task. It enables the mode of what's called safe mode operation to correspond to the selected task. So you can change from a run mode to a jog mode, for instance, and specifying the zones to which authorized personnel have access. and we'll run through this in more detail. But effectively, you've got your safeguarding support system. This will now, in this particular case, we've got our pit reader and our key. If our person comes along with their key, if they're trained, competent and authorized, they'd place their key in the reader, and that would allow them to change the mode of the machine, for instance, or gain access to the HMI. That would determine the permissions that they have and authorize that. And that would then send a signal to the safety related parts of the control system or HMI, etc., to allow them to make those changes. So Technical Report 63074, that provides guidance on the application of 62443, all parts, with respect to aspects of safety threats and vulnerabilities that could affect the functional safety implemented and realized by safety-related control systems, and results in the loss of the availability to maintain safe operation of a machine. And so that looks at safety aspects related to functional safety with regards to security risk assessments, the response strategy based on that assessment, what security countermeasures could be used. It discusses identification and authentication, usage control, restricted data flow such as firewalls, and ongoing review and maintenance of your security measures. So as discussed earlier, really 62443 parts 4 part 1, that kind of describes requirements for security development lifecycle. And so that process is intended to ensure that all security risks in the product are identified and, if possible, eliminated in the product. And as mentioned, the certificate really demonstrates that PILTS is competent in this area of security and confirms really that we not only develop safely, but also securely. So requirements to machine manufacturers and users. So what's kind of like the difference now from conventional assessments to security? So the process for machinery safety and industrial security on a machine, this is kind of what we would follow. So on the left-hand side in the orange, we've got our safety, and then on the right in the blue, we've got our security. So in both aspects, we'd start with our risk assessment. So we'd use 12100 for machinery safety. We'll determine the risks of the machine to humans. We'll determine what performance levels or SIL levels are required. With regards to security, we would look at 62443. We'd look at what risks can occur through manipulation, and we would look at security levels, SL as opposed to SIL. We'd then have a requirement specification, so this could be a safety concept. So how do we gain access to the machine, distance, protection for light curtains, etc. Whereas for security, we'll look at security concepts. So again, how do we protect against unauthorized access? We'd then do our design specification. So we'd look at our protective measures for safety. So for light curtains, what kind of distance would they be at? What height would it need to be? Etc. With regards to security, we'll look at our user management on the engineering workstations and segmentation of networks. And then finally, we'd have our implementation and our safety integration. So it's pretty much the same for both. Those measures would be implemented. We'd then have our verification and validation. So we'd do verification of the correct implementation of the risk reducing protection measures for our machinery. So we'd look at Systema, Pascal reports. We'd then do our functional safety validation once it was installed. But security verification, we do our verification of security measures, but validation is not required. And then with regards to the cycle, there might be annual safety briefings for the machine with regards to safety. But as mentioned earlier, with security, it's going to be far more frequent. So we'd have to look at what vulnerabilities become known within the industry. So we can look at websites such as CERT@VDE or SCS-CERT, and these are IT security platforms that share problems and issues specifically that are in the field of industrial automation. We then have to risk assess those vulnerabilities. Device manufacturers would describe what vulnerabilities they may be or what they found. Machine manufacturers would evaluate these in the context of the machine and the risk assessment, and information would be provided to the machine operators. We then have our patch management. So really for machinery safety, it's really in the event of safety critical faults that we would look to upgrade. Whereas with security, if the vulnerability impacts functional safety, we'd have to apply an update to mitigate that risk. And that's where we use those security platforms, really, those websites to look at that. And we then have the interaction between the machine manufacturer and the machine operator. So you may be familiar with this graphic that we have, which we typically use at PILTS for machinery lifecycle. So we have our risk assessment, our safety concept, safety design, safety implementation, safety validation, and we then have our machinery compliance, for instance, with CE marking, etc. If we look at this for security, so we'd carry out our security risk assessment, we'd introduce our safety concepts, and this is where we'd have a target security level that we'd want to achieve. We would look at safety design. We'd then use 62443 and 63074. We'd use those standards to assist with that. We'd then do our security design. We would do our security verification. We'd carry out some kind of tests. But then this is an ongoing process. So with machinery safety, it typically stops here. But with cybersecurity, it will be an ongoing process throughout the life of the machine. So risk assessments with regards to zones and conduits. So we have our organizational security measures. So these would be kind of taken from 27000. So if we use the analogy of like an airport, so you have security checkpoint rules. So, when you've booked your flight, you're going to get information sent through from the airport or the airline to say what you can and can't take onto the plane, for instance, or take into the airport. So these are operational measures. You probably get and you hear public announcements, don't leave your luggage unattended, for instance. And again, that is all part of their policy, really, and procedures for awareness to passengers. There'll then be physical security measures. So there could be video surveillance, regular police patrols, but then there is identification and authentication. And what we mean by that is, anybody can go to the departure lounge, but only if you've got a ticket can you actually go through. So, to get that, you would go to the ticket counter. Are you the correct person for that flight? You would typically show your passport, for instance. They would identify you and authenticate that you are that person before they issue it. Border control, who am I? Am I allowed to leave or enter? So that's kind of a zone because you're going from one area to another. Boarding the gate, am I allowed to board the plane? Again, you'd have your passport and your ticket checked. So at each point, you're being identified and authenticated against. And if you are that person, then you'd be allowed to go through if you're allowed to. So again, for airport staff with their key cards, are they allowed to access restricted areas? And so if we look at this with regards to the airport, the green zone is our departure lounge. So that's for all members of the public, really. And the red area is your ticketed passenger zone. So that's once you've gone through security. So in addition, each gate within the walkway to the airplane is a zone, and we've kind of highlighted that in blue and in green. So in order to move between these zones, the green and the red area, there's specific rules and they're defined. And so to move from the general public zone to the ticketed area, so the passenger zone, you need to pass the security checkpoint, which is this yellow circle. And you can only do that with a valid ticket, as well as passing the screening of bags, etc. So that's kind of like our VPN and our firewall. There's our rules, etc. that are there. And if you don't meet those rules, then you can't go through. and there you can only do that if you've got the correct ticket, passport, identification, authentication, etc. So as I said, these checkpoints really are kind of like the different rules set between firewalls in the OT and the IT networks. And so then if we look at our system under consideration, so using 62443, we have our IT and we've got our OT networks, so we can zone those off effectively. So this is our IT network, this is our OT network. And then what we're going to do within that is we're going to focus on the OT network, and we're going to start to zone everything together. So we would look at, all of our safety systems, we'd look at all our process, we'd look at our Wi-Fi hotspots, we might look at all our standard PCs, SQL servers, etc., etc. So we'd look at everything that's within that OT network, and we would look to group them, to zone them together. Then from that, we would then look at really the conduits between them. What's the communication between them? What's the influence of one to the other? So, we'd look at maybe maintenance, for instance. What do maintenance need to do? And what devices or zones do they need to have interaction with? And so we'd look at kind of the automation, safety, wireless devices, and all of these really have a flow between them, and we need to then create the rules, etc., between those, depending on the risk assessment and what is the risk to the OT network if it was compromised. And to do that, we would look at foundational requirements and countermeasures. So, this part really is like our risk assessment to a machine. So, if we looked at a machine, we need to put a guard on there. We need to put an interlock on there, for instance. The interlock, the guard, the light curtain, they're really countermeasures that are being used to protect the machine. This is similar, but for security, cybersecurity. So our foundational requirements are broken down into 7. So we have identification and authentication of control. We have use control. We have system integrity, data confidentiality, restricted data flow, timely response to events, and resource availability. So based on our zones and our conduits, we will use either 1, 2, 3, or all of these to be able to combat against those. And that would all depend really on what our risk assessment came back with. And so this is just a breakdown really of those foundational requirements. And really the industrial control system, what we mean with user management, access to authorization systems, certification, authentication with VPNs, etc., malware, protection, application, input, validation. It's just broken down a bit more. So if we look at an example, really, we've got a PSS 4000. As it stands, the foundational requirements there of what it can achieve on its own, but by implementing what we call our PIP mode and our security bridge, which acts as a VPN and a firewall, we can actually achieve all of the foundational requirements if they're required based on our risk assessment, and therefore, we would meet our the requirements of the application for the security level. So our countermeasures. So I'm really going to run through some products now that can help with this. So with identification and access management. So what is identification and access management systems? Well, really we want to protect the business, really. So we want employee protection, liability, productivity, and data. So, we want to make sure our employees are safe. We want to make sure that people just can't turn a machine on and off, even though if it was safe to do so, but we don't want them to do that if it's not right from a productivity point of view. So you want to ensure that only trained, authorized, and competent people can do that. We want to maintain our data and any liability. And so we'll have a number of persons within the organization that are responsible for those things. And then we need to look at what needs protecting. And so we've got access management. So this could be to control systems themselves, HMIs, to areas of the machine. Safe operating mode selection. So we want to ensure that only the correct personnel can change a machine from running to a jog mode, for instance, or service mode. We want to have maintenance safeguarding. So we want to protect from unauthorized startup, for instance. So we can look at 14118. And then we want to ensure machine security as well with our VPNs and firewalls. So we have a number of products now that I can run through that will protect against those and act as countermeasures. So parts of identification access management. So we have a number of ways of doing this. We typically have our key, we have a card, or you can have stickers, or potentially we can use your own card readers, depending on the frequency of those. So that is used to identify as an identification. And on there, really, it would store all the permissions that personnel has. So, what's their training, etc. We can set a timestamp on there so that, if they need to be retrained every 12 months, then we can set a date so that has to happen. It's not going to be kept on a spreadsheet somewhere. So if they come after 12 months and a day, it would prevent access. And then we have the access side, which is really the forwarding of the information, so the authentication of that identification. And we do that through different readers and pick gate boxes. So the identification will be, who am I really? The person, who are they? What hardware can they have basically permissions to, processes, etc. And that could be different for each machine. So depending on your requirements, if I'm familiar with one machine, I might have all admin rights. If I'm not with another one, then you can restrict what I can do to that. So again, it's all based on your qualifications. So are they an operator, service, inspector, line manager, for instance? What level's their education? Are they a beginner, expert? Are they a supervisor? And then kind of what permissions do they have? So they can gain access to the robot, but only level 2, access door number 4. They can gain access page access to HMI page number 14, for instance. They can select English language, but nothing else. So you can kind of control and give permissions for a variety of things for the machine. So it's all based on what we call RFID, near field communication. That's the way that the technology operates. We have an integrated web server, and that's what you can use to program the keys and the permissions. The PIP reading devices can also be networked. So depending on your application, it can either be standalone at the machine, or you can network them together, and you could do it via the supervisor's desk. And then we can also look at operational elements as well. So we can actually control things like the USB switch or an Ethernet switch. So, if you had a contractor come to your site, they can't just connect their laptop to your machine, because that Ethernet port would be down, or the USB port would be down, unless you were trained, competent, and authorized. Then you could enable that Ethernet connection or the USB port. So you can, restrict that access. So if we look at security countermeasures, so with regards to identification and authentication control, we need to identify and authenticate all users before allowing them access to the control system. And so, what we mean by that is we'd insert our key into the reader. That may allow us access to the HMI. So, it would be tailored to the individual. So it's password replacement. We know passwords don't work because they're generally written down, or it's the first thing people ask for. They're written on post-it notes, etc. And it would allow you different control to be able to edit, read permissions on that HMI. What pages can you display? Switching user languages. So we have heard of instances where new equipment has arrived. Somebody who's trained has changed something on the HMI. There's been an issue a couple of days later. Somebody saw what was done. They go into the HMI and cause a problem, and then it takes a few hours to reset the machine. This would prevent that because only trained and authorized personnel would be able to gain access to that HMI screen. That's also the same for the controller or the PLC. So you can control who can activate functions, toggle between different kind of variants, programs, setting recipes, and then activating of the USB Ethernet ports. Then you've got door permissions. So this is really access permissions and management for industrial doors and gates. So only authorized personnel have access. So you may be familiar with kind of trap key systems, for instance, where a trap key system will work safely and in a predetermined sequence, but anybody can use that system. With this, the key is with the person, it's not on the machine. So only if you are trained, competent, and authorized could you actually gain access to that machine. You can just stop it at any time. And then we have the safe operating mode, and this is access permission management, for functionally safe operating modes. So only authorized, trained, and qualified personnel can switch between operating modes of a machine. So that would be from an automatic mode to a service mode, for instance. And again, it stops that kind of, it stops that behavior where, if you see something is wrong, you're trying to do something to help the business out, and that's normally when something goes wrong. It prevents that from happening because you're ensuring that only the trained and competent people can gain access. So we kind of ran through safeguarding support systems, but if I run through that now in a bit more detail, we have identification of the personnel. So that's our kind of driving license or a passport. So there's our identification. So in this case, it's our key, and then that allows the access management, and that's where we've got our different access to either the HMI, safety controllers access, for instance. So if we look at a typical installation, here's our control panel, HMI, got a USB reader, Ethernet ports at the bottom here. There's no identification. The key's always inserted in the panel and can just be turned by anybody, so you've got no idea who's doing what and when. The USB is also directly connected along with the Ethernet port, so anybody could connect to it, charge their phone to it. We've heard stories where people charge their phones, blowing ports. So that's how it stands. With cybersecurity and the changes in the machinery regulation, this would be what it would look like after. And so now the key's been replaced with our key and pit reader. So we've got identification and authentication of users and tracking. The operating mode of the machine can only be selected by trained and competent personnel. We've got data protection via our USB and Ethernet ports, because they can only be activated if the correct key is inserted. So therefore, direct communication with that PLC and HMI, again, is only possible if you are trained and competent to do so. So using encoded transponder keys with RFID technology, each employee can be granted machine approvals and permissions adapted to their abilities, really. And this is where we can look at the functionally safe operating modes, regulation of access, authorization, avoiding incorrect operation, so the machine isn't down when it shouldn't be, and we're avoiding manipulation as well. And this would effectively tick your Can everybody hear me now? Okay, apologies. I don't know what's happened. I don't know what's happened there, everyone. So apologies for that. So yeah, if I run through, really, I'll go. I think I may have lost sound here. So we've got our security measure here against the threat, which is a USB reader. So just to show you really, if you needed to connect to that reader for service, for instance, you'd come along with your key. If you're trained, authorized, and competent, that would allow that PIT reader to be enabled, and you would allow connection basically. So an example again here is really malicious access to USB ports. So we're replacing that with our USB and Ethernet systems and our key to enable the enabling. We've then got usage control, and this enforced the assigned privileges for authenticated users to perform and request actions on the control system and monitor these privileges. And so the screen is in German, but if I came up to this HMI and the key wasn't in the panel, I can't gain access to the HMI, so I wouldn't be able to change anything. But also, if I put my key in, depending on what my competency was and my authorization, would depend on what I can actually select on the HMI as well. So, you know, if I was an apprentice, for instance, and I see one of my colleagues doing something on the machine on a breakdown, if they're not there the next day and the same thing happens, you know, I can't do what they've done because I haven't got the permissions. And so, you know, really you're preventing potential downtimes to the machine and threats to the safety rate parts of the control system through the HMI. So again, the application here is, here's our HMI. We have to put our key in. If we've got the correct permissions on the key, then it would allow for the HMI to be accessed. So then we need to look at foundational requirements and influences on these safety related parts of the control system. And, you know, from that, we need to look at preventing manipulation, really. So we have the permissions. So that's an increase in quality due to clear responsibilities. You have effective know-how, really, and protection of access to sensitive data. And you've got clear user levels, especially on complex machines. And then the transparency really is the individualization of users. So that means that they are identified. Passwords are not secure. So, you know, and not personalized and often known. Actions can be clearly assigned to users, and there's full detection capabilities in the event of a breakdown or an accident. So then we have our restricted data flow. So this is segment to the control system via the zones and the conduits to limit the unnecessary flow of data. So in this application, we've got a excuse me, a PC that could be in Spain, for instance. We've got our machine in the UK, and we want to remotely gain access to that machine. So we have our security bridge, which acts as our VPN and our firewall. And you know, even if the person wanting to connect in Spain has got all the correct permissions for that VPN and the firewall, they can't actually gain access until somebody within the factory authenticates who they are, and then they would put their key into the reader and allow the final permission to allow that data flow. So that meets the requirements of foundational requirements of 2 for use control. We've got 3 for our system integrity, and then we've got 4 for our data confidentiality. And so here's an example here really is, you know, we've got our PC and our PLC. We've got our security bridge with our firewall with the rules. So we create our secured encrypted VPN tunnel. and the pit reader enables the data connection from effectively from inside. So without that, even if you've got all the correct permissions, you wouldn't be able to gain access. We have safe operating mode. And so when the operating modes of machines are switched, i.e. from automatic to a service mode, the safety level can change because the protective measures that are used can be overridden or switched off. And so the machine end user must ensure that only qualified and trained personnel can work in such operating modes. And so in this case, we have our security. So we have our access via the RFID key, and then we have our safety via either a safe evaluation unit, which could be used with anybody's third-party functional safe controller, or within our own controllers via program blocks. And once you insert your key, based on your permissions and your level of competency, etc., and your rights, would allow you to change the mode of the machine based on those permissions. And what these two units here, these devices, are actually evaluating that and then sending an output to change the mode of the machine. And so there is 16090, which is for machine tools, where it talks about modes of safe operation and whether it's mandatory for using this type of system for changing between automatic and setting mode. So the permission is evaluated by inserting the key. The permissions on the key specified which operating mode can be selected. The operating mode is selected by corresponding LED buttons, or it could be a push pad. And the final evaluation of the operating mode is made via a safe control system. So it's a bit out of date, this slide, because there's more than 5 that are possible now, depending on the infrastructure that's used. But typically, you could have automatic mode, setting mode with, say, an enabling switch, manual intervention under restricted operating conditions, again, with an enabling switch, special mode or process monitoring, and a service mode. And depending on your permissions, would depend on what you can select. We also do kind of for machine tool centers. So if you've got an area within your factory with lathes, milling machines, etc., and you only want trained and authorized people to operate those, then you can do that with the pit reader and a key. Go through a network switch to a controller, and depending on your permissions would depend whether or not, if you went to machine tool number 1, whether or not you could actually switch it on and activate it. If the key wasn't in place, you couldn't, and if you wasn't trained to do so and you put your key in, it also wouldn't allow you to do that. And there's just a simple program here, really, albeit there's an error because these should be OR gates, not AND gates. So, key 11, 12, 13, 14, 15, or 17 would effectively allow you to operate machine number 2. But if it was machine number 3, you could just take out key number 12, for instance, and it wouldn't allow that. This can also be used really to assist on 14119 and prevention for motivation to defeat. So that can be avoided by implementing alternative operating modes. And if we introduce modes of operation, this can be really defeating the interlocking device unnecessary, or it makes it unnecessary or unattractive. So by introducing permission keys, such as our pit gate box, with the pit reader, we can restrict operating conditions to authorized and trained personnel only. So only those trained and authorized persons can operate the interlock and stop the machine. But you might also want to run that machine at a reduced speed, and during a setup mode, for instance, and you do that with an enabling switch. You might have a 2-hand controller. You might do that with a incremental encoder, for instance, to determine the safe position and the speed. But this is only allowed through trained and authorized personnel to work safely on that machine, therefore without defeating any locks that are on there. So an example of that is our palletizer. We have all our safeguards around the machine. So normally the gate's closed, it's interlocked, we've got our light curtains with muting, a pallet would go in, be wrapped, then go out. If the operator wanted to do any setup, for instance, they'd put their key into the reader, and if they were trained, authorized, and competent, they could change the mode of the palletizer to say a setup mode. That would then enable the jog control function. It would also override the interlock. It would allow them to set it up. If they removed their key at any time, it would automatically default the safeguards back to their normal position. Another benefit also would be if somebody was to press the e-stop for any reason, you could make it so that only a qualified person can reset that e-stop. And so this is useful if somebody, I don't know, if somebody presses the e-stop because it's always, it's lunchtime, so they always press it, for instance, there's retraining that's required there. Or if there has been an e-stop pressed, really you need to investigate why that's happened. And so, it couldn't just be twisted and restarted. Somebody would have to come, investigate that, put their key in, and then they'd have to restart and reset the system. So examples of operating modes. So you can see we have our pit reader and key, and then we've got our push button to change the various modes here. It doesn't have to be a push button. You could do it via a HMI, or you could do it via push buttons as well. So here's our key. We would press the corresponding button depending on the mode that we wanted to choose. And if our key had the correct permissions and authentication for that key, for that level, it would allow that mode to be changed. If it didn't, it would go red and it would prevent that access. And then we also have maintenance systems. So this is key in pocket that we call key in pocket. So this is where you've got dangerous areas such as robot cells, warehouses with automated storage and retrieval systems. And so if personnel enter an area, what we call whole body access, the machine must be shut down and brought to a safe condition. And only then when the person can then enter the cell and perform their task. But also you don't want that machine restarting whilst they're carrying out that task. And so in this instance, an operator would authenticate themselves, signing in. So if they've got the right permissions, it would allow them to request the machine to come to a standstill. When that machine has come to a safe stop, it would then allow the interlock to be energized. They can gain access. They would take the key in with them, but that key would be logged in the system, so it knows that they're inside. So if somebody was to come along and stop and close that door and try to restart it, it would know that an operator was in there and they've not come out. And if so then when that person leaves, they would sign out, and then it would allow them to restart the machine. And so we can do this with quite complex systems, really. So we have our reader. We'd have what we call our PNOS multi, or we could use a PSS 4000 or universal. We can have our pit gate reader for signing in and out, or we can use a HMI to display the number of people that are in there. And then we can use an LED lamp to have a visual indication as well. And so in this instance, if you've got various gates around a machine, so you don't always have to come in and out of the same gate. You could go in through one gate, or it could be a light curtain, for instance, go through your storage automated retrieval system, and you might have to walk, 100 meters, and you could leave through another gate, for instance. But what you would do is you would log yourself in, you would register yourself when you enter, and in this case, the machine is green because it's running. It's now come to a stop and one person has entered. But if a second person comes in, they would just register their key, and so on. If a third came in, they'd register their key, etc., etc. And this can all be recorded and documented on the HMI and within the system. And we could then see that, myself and others were in the machine, or it may be that you walk past and you identify somebody that hasn't registered. So therefore you can do retraining, for instance. Or if you're trying to see who is on that machine, perhaps to restart, you can identify who's logged in. And that's where we have this kind of system here. So you could enter through one door, but you could exit through another. Yeah, so that's pretty much concludes this morning's webinar on safety for man and machine. As mentioned, there will be a live presentation of all the countermeasures that have been run through today on the identification and access management systems. That will be on Thursday, the 23rd of May, and you should receive a link to that. And it will be interactive, or should be interactive, hopefully, with the technology, so that you'll be able to ask any questions that you have, and we can answer those during the live presentation. And all our previous webinars and this one can be found on our GoToStage channel, which you should all have links to, and you can all have a look at previous presentations. So yeah, that just leaves me to say thank you for attending this morning. I hope it's been informative and useful. If you have any questions, please let us know. Hopefully we've answered any that you have, and have a good weekend. Thank you.